Hello guys, and welcome to my first devlog video of the game that I'm currently working on. Well, it's not actually really a game yet, it's very bare bones at the moment. As you can see, this is literally all the code there is for the game at the moment, and there isn't much yet. The rest here is the source code for the engine. In this series I'll be focusing on the game, but maybe I'll do a separate series on the engine too if that's something that people would be interested in. So first up, I should probably tell you what kind of game I'm making. I'm making a 3D action-adventure game that takes place in a procedurally generated world. Kind of like Minecraft, but more focus on the combat and progression elements. I think Terraria is probably closer to what I'm trying to make than Minecraft. So this video is going to cover my first week of progress on the game, which is basically world generation and generating voxels using Perlin noise and creating meshes from that using marching cubes. It's not much yet, but we gotta start somewhere. So in order to be able to have very large or possibly infinitely large worlds, I'm going to be dividing the world up into chunks. Each chunk will be saved to a separate file, and we can load and unload chunks as we need them. Each chunk is further subdivided by a number of sections, or batches as I'm currently calling them, and each batch consists of 16 by 16 by 16 voxels. The chunks themselves contain 8 by 8 batches in the X and Z directions and a variable amount of batches in the Y direction. This way we can always adjust the world height if we would need higher worlds later on. The voxels themselves are simple 32-bit structures. We want to keep this small as we're going to have to store a lot of these. The structure itself consists of a 2-byte index into a voxel definition table. Each table entry here contains some more information about the specific type of voxel, for example its color, whether it's grass or dirt, or maybe some other physical properties. The 2 remaining bytes in the voxel structure I'm using as arbitrary state for each voxel. This can mean something different depending on which type of voxel we're talking about. For destructible voxels, for example, you can use this as an HP value that keeps track of the damage to that particular voxel. So now that we've got that out of the way, let's try to actually generate something that we can visualize. For this, I'm going to be using Perlin noise. There really are a lot of good videos on YouTube explaining how Perlin noise works, so I won't go into a lot of detail, but I'll give you a quick overview of what this is. Basically, Perlin noise is a type of coherent noise. Coherent meaning that samples close to each other will have only a slight difference in value, as opposed to just random noise, where every sample is just random. So how Perlin noise works is you have a grid of randomly generated unit vectors called gradients, and when you take a sample at a specific position, you first determine the grid cell where the sample lies, so you know which gradients you will be using. Once you have this, you calculate the dot products of the gradient in every corner with the vector pointing from the sample point to the corner point. Then you interpolate these dot products based on the sample position. So first we interpolate horizontally, leaving us with 2 values remaining, and then we interpolate those 2 vertically, giving us the final result. If you create a texture using this and you do this for every pixel, you get something like this. It doesn't look too bad, but it also doesn't really look like something that we could use to generate terrain. However, if we do multiple iterations of this algorithm per sample and choose different cell sizes and use different weights to add all the results together, we get something like this. So what I've just explained is the 2D variant of Perlin noise, but it can also be generalized to 3D or even n dimensions. For now, I'm just going to use 3D Perlin noise to generate some voxels, but I'll end up changing this to a combination of 2D and 3D later. Okay, so now the only thing that is left is that we need to generate some geometry around the voxels. If we would, for example, generate a cube for every voxel that has a value higher than some threshold, we would get something that looks a bit like Minecraft. This is, however, not really the style I'm going for, so instead we're gonna use marching cubes. With marching cubes, you iterate over your grid of voxels, each time taking the 8 voxels of the current cube.
A few moments later.
Have a total of 2 to the power of 8, or 256, different configurations. Each configuration results in a different set of triangles made up out of connecting these center points.
Lot of boring math later.
If we calculate and generate all of those shapes ourselves, it's actually much easier to just grab a pre-made triangulation table for this off the internet and just use that. So when you put everything said in this video together, it looks something like this. Now bear in mind it doesn't really look like terrain or anything like that yet, because we're basically just using Perlin noise and nothing else. We're not like scaling the results or like shaping them into something that we want. All of that stuff will come later. But now we have the foundations upon which we can build. So that's it for me for this video. I hope it wasn't too much information. I don't know yet if I'm going to upload a video every week. Next week is mainly going to be backend stuff where I won't really have a lot of footage to show. So depending on how that goes, it might be 1 week or 2 weeks. In any case, I hope you enjoyed the video. If you did, please consider subscribing and stay tuned for more. Thanks.